To make a sign chart, you're going to label the vertical asymptotes, if there are any holes, and x-intercepts, if there are any, okay? So on your sign chart, you're going to use vertical asymptotes, holes, and x-intercepts. Okay, so on this graph for my sign chart, what were the vertical asymptotes? We've got -2, +3, okay? And if you want, you can write vertical asymptote so you know where that number came from. Okay, there were no holes, and then the x-intercept was at 1. Okay, so as long as these go in order, as long as my smallest one's first, and then it goes the next one, and then it goes the next one, then the actual spot on the line doesn't matter. Okay, I don't need to count my spaces in between the 1 and the 3. I just have to have the 1 and then the 3. Okay, so what I'm trying to do with my sign chart is I'm going to look at my equation, and I'm going to pick a number that's between -infinity and -2. Okay, so any number from the end of -infinity until -2. So you could do -3, or you could do -20, or you could do -100. Okay, so any number in this interval. So let's do -7. Okay, and I want you to write this -7 super small so that you're not confusing it with your number that we're going to on our line. Okay, so if I plug a -7 into this equation, I get -7 minus 1 divided by -7 squared minus -7 minus 6. Okay, so -7 minus 1, I don't care what the number is, I just know it's negative. That's all I want to know, is it positive or negative? Okay, and then on the bottom, I've got a +49, and then I'm adding 7 and subtracting 6. So this is going to end up being a positive number, right, when I add those all together? So altogether, if I divide a negative by a positive, I'm going to get a negative number. Okay, so what that means is between -infinity and -2, the graph is below the x-axis. Okay, so I could sketch the graph below the x-axis now, because I know that it's going to be between -infinity and -2, it's below the x-axis, right? Okay, so if it's below the x-axis, look over at your graph, okay? Between -infinity and -2, it's going to be below. So is that going to be like up on the top or down on the bottom? What do you think? The bottom. Okay, so when I look at my graph right here, graphs always hug the asymptotes, right? They want to stay as close as they can to that asymptote, but they never can touch it. No touchy, okay? So it's either going to follow the asymptote like this and then go up, or it's going to follow the asymptote like this and then go down. So is this below or this below? The bottom one is, right? So this side of the graph from -infinity to -2 is going to look like this. Okay? And then we keep doing it again. So now I pick a number between -2 and 1. Okay? So pick a number between -2 and 1. There's a pretty easy number, 0. We already know what the answer is at 0. Did you get a positive or a negative on the y-intercept? It was positive. So that means between -2 and 1 right here, that graph is going to be up above the x-axis. So it's going to start next to the asymptote up here. It always is going to be next to the asymptote, okay? And it's going to come down and it's going to hit the y-intercept, and then it's going to hit the x-intercept. Okay? So it's going to start positive up here. It's above the y-axis. It's going to come down and cross the y-axis hit the x-axis. Now I have to figure out between 1 and 3 if the graph's going to go up and be positive or if it's going to go down and be negative. Okay? So you have to figure that out. So pick a number between 1 and 3. There's pretty much only one you can do, right? Unless you want to put a fraction in. So choose 2. If you put a 2 in place of x, do you get a positive or a negative number? That's what we're trying to figure out. Okay? So put a 2 in place of x. See if we get a positive or a negative number. Well, 2 minus 1, 2 squared minus 2 minus 6. So the top's positive, and the bottom, this one's actually going to be negative, right? So between 1 and 3 is negative, which means on the graph it's going to go down and cross, okay? So it's going to keep going down. It doesn't always have to do that. Sometimes it bounces back up, okay? And then the last one is between 3 and infinity. So pick a number between 3 and infinity. I don't really care what you do. Do 5. 5 minus 1 divided by x squared. So 5 squared minus 5 minus 6. Positive. 25 minus 5 minus 6 is also positive. So this is going to be a positive number. Okay? So if it's positive, draw your graph on this side. So from 3 to infinity, draw your positive number. Okay? Or your positive graph. So it's above the x-axis and it follows.
No. Really not
Okay. So the signs aren't going to always alternate. They sometimes will. Like on number 2, they're not going to alternate. So see how this one went minus, plus, minus, plus? That's not going to happen on number 2. Okay? So let's do. Okay? So we get this graph and we see it's going to be positive, so it's going to be above, and then it's going to go towards the asymptote. So what you want to check is that since this is a horizontal asymptote, I want to make sure at the end that my graph is right next to it. Okay? See that? How it makes that line right next to it? Okay? So now that we have our graph, we can answer the rest of these questions. So if you start at the bottom of the graph right here, and you went up to the top, you're covering every single value, right? So even though the 0 is an asymptote, I still have a spot at 0. So the range is going to be negative infinity to positive infinity. Okay, so even though we have that asymptote, I don't have to stop there because of the x-intercept. If there wasn't an x-intercept, I would have to stop at 0. Okay? All right, so continuity. This means, can I draw the graph without picking up my pencil? So on this one, put your pencil right here. Draw this part, and then you have to do what? Lift your pencil up, right? So this is going to be discontinuous. There's a couple of types of discontinuity. Mainly, we're going to focus on infinite ones. Infinite. What am I missing here? Okay. So infinite means I have a vertical asymptote. It doesn't matter what else you have. If you have one vertical asymptote, it is infinitely discontinuous. It will never be continuous. Okay? Forever. All right. So, and then what do you notice about the graph on increasing or decreasing? Yeah, it's always going down, down, and down, right? So we don't want to say it's decreasing from negative infinity to positive infinity, though, because we have places where it stops. So we want to copy the domain, okay? So everywhere my pencil was, right, everywhere where I have my graph, it's decreasing, and that was the same as my domain. So my domain and decreasing are going to be the same. That's not always true. It's just on this graph. okay? And if it's always on the domain decreasing, then that means it's never going to increase. Which means there's no max and no min. Now, you can put a dash like this, or you can write none, but do not leave it blank. Okay, you have to show that you knew how to do it, that you didn't just leave it blank. So I've got none and none. Now on symmetry, remember we talked about even and odd? So this one is not even, right? If it was even, I'd have them on the same sides. And then odd, I look and see, did it go through 0, 0? So if you want to write this in your notes, this is one that gets mixed up a lot. So even is y-axis reflection. Okay, so it's like this. And then odd has to go through 0, 0. Okay, so it doesn't, it's not even, it's not odd, so I write neither. So symmetry is either even, odd, or neither. It has to be one of those. You can't ever do two of them. Okay? All right, and then the last thing you have is your positive and your negative, which you have over here on your chart already. So you just need to write your intervals. Okay, so it starts out negative. So from negative infinity to negative 2, it's negative. And then again from 1 to 3, right? So put your negative, negative, and then positive, positive on your answer sheet. And I don't want to go through the whole thing with you on the next one, but I do want to start some of it with you. Okay. You should have that first one finished, and if you click the note, that means you had it finished twice, and hopefully you really understand it now. Okay, that's fine. I knew it was a long video, but I also know when you see it once, it can be confusing. When you see it twice, it kind of will clear up some of that confusion. So if you watch the video, you're better off. Okay, let's look at number 2. Yes. Yes.
Okay.
The only time you don't include the u is going to be on your x-intercepts because they're not intervals, it's a point. Okay. Anytime you have an interval, you use the u. So let me just finish this so you can have this right. So the negative is going to be negative infinity to negative 2, and then 1 to 3, right? And then positive is going to be negative 2 to 1, and 3 to infinity. Okay? So everybody has 100% on the first one. Okay. All right, let's look at number 2. So now we've got x minus 3 divided by x squared minus 9. Okay. What's our first step? Factor. So if you're looking at that one and you're like, oh, I can't factor that, then you don't have bells ringing in your head. Ding, 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 ding. Why will this factor? What's it called? Good. I'm hearing many things, but they are squares. So x and x, 3 and 3, right? So when I factor this, it's going to have the plus and the minus because it was a square minus a square. So that gives us x plus 3 and x minus 3. Okay? All right, so now that it's factored, see, write down your restrictions. So you always write the restrictions down before you simplify. make your little chart like I did on the restrictions and the vertical asymptote and the hold.
Um,
So once we stack through this, do any of these cross off? Which one will cross off? The x minus 3 will cross off. Good. What does it leave in its place? What's on top? A 1. Okay, so the x minus 3 will cross off. Let me write this first. So x plus 3 and x minus 3 equals the negative 3 and the 3. Okay, so in our chart, we're going to have the negative 3 and the positive 3. And I'm going to be left with 1 over x plus 3. This is our reduced function, okay? So over here on your paper, write f reduced 1 over x plus 3. Okay, so we have the reduced function written down. Okay, awesome. So now you have to figure out which one of these crossed off. Okay, did the x plus 3 cross off or the x minus 3 cross off? The minus 3 crossed off, which gave us the x equals 3, right? So where you have the x equals 3, you're going to move it, and it's going to become a whole. Okay, so I'm going to find the y value in a minute, but this is the x value of the whole. A whole is a point on the graph. It's just an open circle. Okay, but the negative 3 didn't cross off, so that's still going to be an asymptote. Okay, and remember after we crossed it off, we got 1 over x plus 3. So I'm going to take that 3 that we just got and put it in place of the x. And that gives us 1/6 as our whole. Okay, so whatever you get for your reduced function, take the value, the x value for the whole, and plug it in. And that gives you the y value of the whole, because you need to have the x and the y. Okay, so now go over to your paper and graph your vertical asymptote, which we got is negative 3, right? So x equals negative 3 is a vertical asymptote. And then right underneath where it says vertical asymptote on your paper, write whole. And write 3, 1/6. And then go over to 3, 1/6, which is just barely above the x-axis, and draw a little hole. Okay. So now, from here, what's the horizontal asymptote? The top is smaller, right? So what is it? 0. Good. So horizontal asymptote, y equals 0. Draw your dotted line. Okay. Let's do domain. Okay, what values have an asymptote or a hole? Vertical asymptote or a hole? Well, it's the same thing that you got for your restrictions, right? So it can't be negative 3 and it can't be positive 3. But it can be anything else. So write your domain. Okay, so the first interval of the domain is going to be that negative infinity to negative 3, and then negative 3 to 3, and then 3 to infinity, okay? All right, x-intercept. What do we do for the x-intercept again? Top equal to 0. Does that work? 1 doesn't equal 0, so there is no x-intercept, okay? Y-intercept, what do we do? Plug a 0 in for your x, 1 over 3. So the y-intercept is 0 and 1/3. Go mark it on your paper. Okay. All right, so now that we've done that, is it continuous? It is not continuous. There is a vertical asymptote, so what do we write? Discontinuous what? Infinite. Good. So forever. Okay, let's make our sign chart. This is gonna, let's see if you remember how to do the sign chart. What things do we mark on the sign chart? Everywhere it's going to touch the x-axis is where we're going to mark on the sign chart, because that's where it can change from positive to negative. Okay, so that's going to be your restrictions. And x-intercept. So the difference on the sign chart and the domain is if I have an x-intercept, it doesn't affect the domain. But if I have an x-intercept, it might change the positive to the negative. Okay, so on the sign chart, we're going to have any restrictions. So -3 and +3. This was an asymptote. This was a hole. And then we didn't have any an x-intercept, right? So on this sign chart, you're just checking these 3 intervals. Just check those 3 spots. Use the equation 1 over x plus 3. Okay, go ahead and do that. I'm going to walk around and see how we're doing.
So,
It's a number between negative infinity and -3 and plug it in. And -15 plus the times. What we just have to do. It's all in your cute little brain.
I don't know.
All right, so we got the sign chart. Okay. So you should get for your sign chart a minus, a plus, and a plus, right? So that means between negative infinity and -3, the graph is below the x-axis. So it's going to be the same as this one, right, where it's below. So it's just going to go like this. Okay, what about in between the asymptote and the whole? It stays above, right? It's positive. So this is going to start next to the asymptote, and then it's going to cross y, and then it's going to go to the whole. So it's going to start here, cross y, and go to the whole. Mine didn't quite cross where it's supposed to. But.
Where did it need to cross? Oh,
So it has to cross y, so it's going to start from here, and it has to go to here, right? And then it's going to go to the whole from there. Now remember, this is an asymptote, right? So sometimes it can cross over the asymptote and stay next to it, or sometimes it stays right above it, but it's going to be next to the asymptote. So since you got a plus plus, that means it just stays right here, right along that line. And it almost looks straight, but it keeps going down really, really slow forever and ever and ever and never touches. It just gets closer and closer to that asymptote. Okay? So when we do that, what that told us is the positive and the negative. So fill in your positive and your negative. Now, when you do the positive, because there was a hole, you do have to stop at 3. Even though it's always positive from here to here, I'm going to go negative and -3 to 3, and then 3 to infinity on the positive, okay? So negative, I keep saying infinity, -3 to 3, and then 3 to infinity. And then the negative is from negative infinity to -3, just like your sign chart said, okay? No min or max, no symmetry. Can you do the end behavior?
wait, are we just doing day 1 tonight?
Yep. Yep, day 2 is next time, and then that's what we're doing this week.
Is it going to be just on this one in the back?
No,
There's no substitute?
no. Okay, all right, let's talk about range, and then I'm going to let you keep working, okay? So for the range is bottom to top. So let's draw a line like this. So here's negative infinity, here's positive infinity. Looking at the graph that we drew, see if I can show both of them. From the bottom to the top, so this first part starts at negative infinity and it goes up till where? Where does this one stop? 0. So I have to stop at 0, okay? So I'm going to put a hole at 0, not a hole, but a parenthesis. Okay, and then this is the tricky part on this one. We have a hole right here at 1/6. Right, this is the y value. So I'm looking at y values now. So this range is going to go from negative infinity to 0, and then 0 to 1/6, and then 1/6 to infinity. It's going to stop at those two places. But if I look between here and here, this is 0, right? And this is 1/6. There is values in between there. So that's why I have to include that 0 to 1/6. And then 1/6 to infinity. Okay? So the range is going to be negative infinity to 0, 0 to 1/6, and then 1/6 to infinity. And that is pretty complicated. Okay? So if you're barely grasping that, that's normal. This one is never increasing either, right? So decreasing is going to be everywhere there's a line, which is on the domain, right? So it decreases on the domain.
So we did number
Yeah. Okay, on the back side, number 3. We only have about 3 minutes, so I'm going to get you started on this, okay? So right here, this is an absolute value graph, which I know is a V shape, right? And what way does it move where it has the x minus 3? What way does that move? That's to the right 3, because it's opposite inside the bars, right? And then the minus 5 is going to be down 5. So go right 3 and down 5. And that's going to be your bottom of your V, okay? And then the 1/2, that's just your slope. So go up 1/2. You guys can't see that. Up 1/2, up 1/2. And you're going to have to keep doing that because it's going to cross the x-axis, okay? So you need to know where it crosses the x-axis out here. And then do the same thing this way. Up 1/2, up 1/2, up 1/2, okay? And you just keep going. And then using that, we'll write the graph. One thing I want you to know about the range, where's the bottom of the graph? It's down here at -5, right? If I put a line right here, that would be -5. Is it touching that -5? So what do I use? Bracket touches, right? So it's a bracket -5 to infinity. There's no asymptotes, there's no asymptotes, right? And then I could do the rest of that.